Okay, page 23, 2C. What we're required to do here is sketch the domain of these two functions. And what I have here is a graph of the natural log of x. And you can see here from the graph, the only values of x I'm allowed to plug in are positive values of x. So basically what you want to think of is the stuff in here, no matter how complicated it might be, in our case it's this, it has to be greater than 0. Okay? It can't be equal to 0, it can't be less than 0. So the domain for this is, it must be where x squared minus y squared is greater than 0. That must be it. But it tells us to sketch it, so we need to go do a little more work here. So this implies that x plus y times x minus y is greater than 0. So we have the first possibility, in order to create something that's greater than 0, is I multiply something positive by something positive. So the first situation is, this is x plus y is greater than 0, and x minus y is greater than 0. So that implies that x, let's do y first, y is greater than negative x, and y is less than x. I bring the y over here, it's less than x. So what is, I have to have both of these. So y greater than negative x, here's negative x. That's y equals negative x. Maybe I'll larger. And y equals x is over here. Y equals x. Those are those lines. So for y to be greater than negative x, that is the stuff above negative x. And for y to be less than negative x, or less than x, that is all of this stuff down here. So the two together having to happen is this region right here. Okay, that's the first situation. The second situation is if they're both negative. So x plus y is less than 0, and x minus y is less than 0. So this gives us y is less than negative x. And this one is y is greater than x. Negative x is like so. Y less than negative x is all of this stuff. Y greater than x, here's y equals x. When y is greater than that, it's all of this stuff. And so this region right here is what I get for this second condition. So if I put those two together, from this situation I get that little wedge here, not including the boundaries. And from this situation I get this little wedge right here. So this is the domain for this function right here. Okay, the second part of the problem is this, and we'll see if it's any different than that one. Realize that this, because of this rule for logarithms, if I put these two together, I get this one. So let's see if there's any difference in the domains between it when I write it this way instead. Okay, so what I have to have in this is I have to have both of these guys. I need, at the same time, I need x minus y is greater than 0. That's from this guy, okay, because anything inside there has to be greater than 0. And not just that, I need x plus y to be greater than 0. That's all I need. If both of those things happen, then this is okay. Okay, so notice that that's just this situation right here. It's exactly this situation. So when you write it out this way, even though you could combine them and become this, you lose information. So these are really different functions because they have different domains. We do not get this extra part here. This is not part of the domain of this function. It's when you combine them that you get these extra positive things in this term here. Okay, so the domain is the same as this example. And this one corresponds to y is less than x, and this one corresponds to y is greater than negative x. Y greater than negative x is all of this. And here's x. That's y equals x. That's y equals negative x. Okay, if I'm going to be less than x, then I'm talking about all of this stuff. And the stuff, this is and, I have to have both situations. So we're right here. It's the same as this. So it's just a nice clean version. Okay, that's the difference between these two functions. It's very subtle.